Guys, can you all hear me? Can you all hear me? All right, people. So, good evening and welcome back again to your Unacademy Reading English channel. I hope all of you are doing well. So, quickly, let me know in the chats if all of you can hear me, if I'm perfectly audible, visible to every one of you. Quickly, my dear students. Let me know quickly in the chats if all of you can hear me, if I'm perfectly audible, visible to every one of you. Quickly, quickly. Good evening, people. Good evening. Good evening. Good evening. Good evening. So what's up? How are you all doing? All well? Yeah? All well, all well. All well. Sir, you are looking smart. When was I not looking smart? Just tell me that. Huh? When was I not? So quickly, people, let me know in the chats with some fire emojis quick if all of you can hear me, if I'm perfectly audible, visible to everyone. I want the chats to run continuously. Yeah, I want the chats to run continuously. They should not stop. They should not stop. All right. Perfect, 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 perfect. So my dear students, as you all must be knowing, today, what exactly we are going to do? We are going to solve some 100 to 150 questions of your inorganic chemistry. Okay? 100 to 150 questions we are going to solve in this particular session from your inorganic chemistry section. Right? I mean, whatever types of the questions can be framed, can be asked from the inorganic chemistry. I'll be showing you all of them one by one. Okay, and from this particular session, you can expect similar type of questions in your NEET 2025 examination as well. Perfect. But my dear students, in this particular session, it's going to be short and precise only. I mean, I'll not take more than 2 hours. I think in 2 hours, we'll be done with these 100, 150 questions. Okay. But I would want you guys to be very, very, very active in the chats. Okay. I would want you guys to write the answers in the chats continuously. Perfect. That's how the session is going to be interactive. That's how it's going to be a fun session. Otherwise, it's going to be a boring session. You know that. Yes, I've introduced all the models of the questions from the inorganic chemistry, right? Nothing will be asked out of these patterns, these models, right? Which I have come up with today's session, in the today's session. Perfect, people. So already, let me know in the chats quick. All ready, people? All ready? All ready? Quickly, I would want some Josh in the chats. Yeah, I don't want the chats to be very dull. I want some Josh in the chats. Then I'm going to start. Yeah, the chats should run. The chats should run. Perfect. Perfect, people. So, without wasting a lot of your time, let's get going. Let's get started. First of all, with the chapter, that is your period table. Okay? This is your first chapter of your inorganic chemistry. Periodic table. And my dear students, I've included 3 chapters in the today's session. One is period table, one is chemical bonding, and one is coordination chemistry. 3 chapters I've included in the today's session. So from these 3 chapters, whatever questions can be framed, all those you'll be finding in the today's session only. Right? Perfect. So Let's get going then. Let's get started with the first question, which is on your screen. Look at the question, read the question, and tell me the answer in the chats. The IUPAC symbol for the element with atomic number 119. What is going to be the answer of this particular question? A very basic question, and these sort of questions are asked in your examination. Quick people, everybody. See, a lot of students are giving the incorrect answer. My dear students, I'm talking about the atomic number 119. I'm talking about the atomic number 119. 1 is your un. 1 is your un. And what is this 9? It is En, right? N. At the end, you mention what? IUM. So if you see, what is going to be the symbol as per this? The symbol is going to be UUE. So UUE is going to be the symbol of the element which has got the atomic number 119. These are the silly mistakes which you do in the examination as well, right? But you're not supposed to do that now. You're not supposed to do these mistakes. Perfect? These silly mistakes you have to avoid, my dear students. You just saw 9, and when you saw 9, I'm pretty much sure you must have thought 9 means N, right? 9 starts with N-I-N-E-N. So you gave the answer as UUN. It's not UUN, it's UUE. It's ENN basically. Perfect? All right. And do keep on letting me know in the chats whether it's +4 for you or -1 for you. Okay? I would want to know that in the chats continuously, whether it's +4 or -1. Perfect? And do let me know honestly. Chalo, this was the first question, and I believe it's clear. All right. Look at this question and think about it. What do you think is going to be the answer of this question? The element whose atomic number is 114 has been discovered recently. It will belong to which of the following group, and what would be its electronic configuration? What do you think, guys? What do you think? Quickly. Look at, first of all, the atomic number of the element. Atomic number of the element is 114. So which group it would belong to? What would be its group number? I've taught you all this in detail. If you remember, in periodic table, I have discussed every single thing in detail. Its group number is going to be the last 2-digit numbers. Last 2-digit number is 14. So group number 14. Group number 14 means which family? So the element will belong to carbon family. The element will belong to carbon family, right? Okay. Now, do you see any of the options here wherein carbon family is mentioned? Yes, it's option number 1, right? Perfect. So option 1 is going to be the correct answer of this particular question. So tell me, is it +4 or -1? Quick. Tell me, is it +4 or -1? Quick. Quickly, people. All right. So majority got the +4. That's great. Now look at this particular question. What do you think about this one? The question says an atom has electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, 3d3, 4s2. 3d3, 4s2. 3d3, 4s2. That means the element belongs to which block? It's a D block element. See, S is filled. S is already completely filled. Now D is being filled. Perfect. So it's a D block element. What do I have to check? You will place the element in which group? You will place the element in which group? Group number for D block elements. Dear students, if you remember, group number for D block elements is going to be equal to Ns electrons plus N-1 D electrons. See, this is your Ns and this is N-1 D. Ns is carrying 2 electrons, N-1 D is carrying 3 electrons, so 3 plus 2 makes it 5. So group number of this particular element is going to be what? Element will be in the 5th group. Perfect. This sort of a question you should be knowing from now onwards. All right. Okay. What do you think about this one? Again, a simple question. You should be able to answer this one as well. The element with atomic number 118, atomic number 118 will be alkali metal, noble gas, lanthanoid, transition element. What do you think? First of all, look at the atomic number. It's 118. What is going to be the group number as per this atomic number? Group number is going to be last 2 digits, that means 18. Group number 18 means noble gas. So this particular element will belong to what? It will belong to noble gases, right? So it's option 2. That's going to be the correct answer of this particular question as well. Perfect. Keep on checking whether you are guessing all the questions correctly or incorrectly, okay? Look at this particular question. One famous question which is asked frequently in your NEET examination. The correct order of the ionic radii. O di negative, N tri negative, F negative, Mg di positive, Na positive, Al tri positive. All these ions which are given to us, all these species which are given to us, they are isoelectronic. They are isoelectronic species. They have got same number of electrons. Isoelectronic species. And in case of isoelectronic species, remember one simple thing. When you talk about the size of the isoelectronic species, size is directly proportional to what? The negative charge. Inversely proportional to what? Inversely proportional to the positive charge. Just remember it like this. This is more than sufficient, and you can solve all the questions based on this particular stuff which I'm telling you right now. Okay, so size is directly proportional to the negative charge, inversely proportional to the positive charge. Now tell me what is the answer? More the negative charge, more is going to be the size. So more negative charge. Nitrogen has got the maximum negative charge, followed by oxygen, followed by chlorine. So N tri negative will have maximum size, O di negative, then F negative, right? So I feel option 1 is only the correct answer over here, as per the thing which I gave you over here. Okay? Perfect, people. I hope this is clear. In case of isoelectronic species, remember size is directly proportional to the negative charge, inversely proportional to what? Positive charge. That's all. Okay. Now tell me the answer of this question as per the same concept. Tell me the answer of this question as per the same concept. Again, you are given with the isoelectronic species. Again, you are given with the isoelectronic species. Again, talk about size. Size is directly proportional to negative, inversely proportional to positive. Where is negative charge maximum? Negative charge is maximum on sulfur. Okay, so sulfur will have the maximum size. I mean, S di negative will have the maximum size, right? Then you have got Cl negative, right? Perfect. So tell me what is going to be the answer, quick, everybody. This is something which you should be able to solve, guys. Quickly, everyone. Everyone, I want the answer in the chats. It's absolutely going to be option A. It's absolutely going to be option A only. Simple concept which I gave you. Size directly proportional to negative charge, inversely proportional to positive charge. That's all. That's all, people. All right. This is one more question which is frequently asked in your different examinations. Okay. What do you think about this? For the second period elements, the correct increasing order of the first ionization energy. See, guys. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. On moving from left to right, what happens to ionization energy? Generally, on moving from left to right, ionization energy increases. Ionization energy increases. So what has to be the expected order? What is the expected order? Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. So this is supposed to be the expected order. This is my expected order. But is this the actual order? No, this is not the actual order. This is not the actual order. My dear students, in order to write the actual order, see where you have to think. This is your beryllium. Look at this beryllium. Beryllium's outermost configuration is 2s2. Okay. Boron's outermost configuration is 2p1. Beryllium's outermost configuration is 2s2. Boron's outermost configuration is 2p1. This is your 2s2 configuration, and this is your 2p1 configuration. Perfect. This is completely filled configuration. So to take electron out from this completely filled configuration, more energy has to be supplied. Perfect. That is the reason why beryllium has more first ionization energy than that of boron. In case of nitrogen and oxygen, nitrogen has got the outermost configuration of 2p3. Oxygen has got the outermost configuration of 2p4. This is the half-filled configuration, right? to take electron out from half-filled configuration, you have to give more energy. That's the reason why nitrogen has got more first ionization energy than that of oxygen. Perfect. So this is now going to be the actual order. Now look at the options and suggest your answer. Look at the options and suggest your answer. The answer is going to be which one? The answer is going to be which one? It is going to be option 2. That is going to be the actual answer of the question. So be careful with this particular question as well. Okay. Now, my dear students, we are given with the group 16 elements. O, S, Se, Te. These are oxygen family, group 16 elements. Now, as per this particular question, we have to arrange these elements as per the correct order of electron gain enthalpy. Electron gain enthalpy. Now, you already know the general trend. On moving from top to the bottom. Electron gain enthalpy, does it increase or decrease? It decreases. So what should be the expected order? Oxygen should have maximum, then sulfur, then Se, then Te. This is the expected order. But is it the actual order? This is not the actual order. Why is that? Because of the smaller size of oxygen, its electron gain enthalpy would be the least, basically. So sulfur, actual is going to be sulfur, Se, then Te, oxygen you'll be keeping at the end. So this is the actual order of electron gain enthalpy. So do remember this particular question as well. So it is absolutely going to be option A. That will be the correct answer of this particular question. Right? I hope you are remembering all of this. Look at the next one. Look at the next one, people. Look at the next one. In which of the following options, the order of arrangement does not agree with the variation of the property indicated against it? Basically, which of the option is wrong? Option is wrong? See, Al tri positive, Mg di positive, Na positive, F negative. These are isoelectronic species, right? Increasing ionic size. This is the increasing ionic size. This is correct. This is the order of increasing ionic size. This is correct. Look at the second one. Boron, carbon, nitrogen, oxygen. Increasing ionization energy. Recently, few minutes back only, I told you nitrogen has got more ionization energy than oxygen. So this is the one which is going to be our answer. This is something which you are supposed to check. So this is wrongly given basically. I believe this is clear. People. Okay. All right. Look at this particular question. Tell me its answer. Quickly, people. Quickly, people. Everyone. Everyone, quickly. What is the answer? Quick. So, which all elements are given to us? We are given with oxygen. We are given with sulfur. We are given with fluorine. We are given with chlorine. First of all, in the group, if you compare we have to compare what? Electron gain enthalpy. Okay. If you talk about this is group 16 and this is group 17, you know it. And we know chlorine has got more electron gain enthalpy than that of fluorine, right? And sulfur has got more electron gain enthalpy than that of oxygen. So what should be the order as per you? Order is like this. Chlorine has got maximum, then comes your fluorine, right? Then comes your sulfur, and then comes your oxygen. So this is going to be the order. Look at the options. Chlorine has got maximum, then fluorine, then sulfur, then oxygen. So option 2 is the one that's the correct answer of this particular question as well. I hope you can solve this sort of a question if it comes in your exam. Okay? What do you think about this particular question? These are some oxides which are given. You have to identify which oxide is neutral, which oxide is basic, which is acidic, and which is amphoteric. First of all, if you look at the first option, Na2O, Na2O, all of you must be knowing, this is the oxide of alkali metal, right? Which must be basic, So you'll be attaching this one with this B. Attach one with B. One with B here, one with B here, right? Now, Al2O3, you must have heard Al2O3 is the amphoteric oxide. If it is the amphoteric oxide, so 2 you have to match with D. 2 you have to match with D. So here only I got the answer. N2O. N2O is neutral. Cl2O7 is, right, acidic. Perfect. So option 1 has to be the correct answer of this particular question as well. I hope this sort of equation, again, you should be in a position to solve easily on your own. Look at this particular equation. Quickly, guys. Quickly. Siddharth, you can follow this particular session. I mean, these sort of sessions which I keep on taking here, these are going to be super beneficial, and I'll be providing the PDF of this particular session on my Telegram, which is Wassim Bhat Chemistry Official. Okay. Outer electronic configuration of group 13. Element E is 4s2 4p1. Okay. The electronic configuration of the element of the P block, period 5, placed diagonally to the element E is. What do you think? What do you think about this question? Think over it, guys. Quickly, guys. Everyone, think over it and then let me know the answer. Think over it and then let me know the answer. See, if you talk about your group 13 elements, group 13 elements are your boron, aluminium, gallium, indium. I do not have to go far. This much is enough, right? What about your group 14? Guys, it's pretty much simple. It is pretty much simple. See, what about the outermost configuration of boron? It is 2s2 2p1. This will be 3s2 3p1. This will be 4s2 4p1. Which element they are talking about? Group 13, who has got the configuration of 4s2 4p1. So they are talking about gallium, right? They are talking about gallium. Now, which element in the group 14 is diagonally related to gallium? That means the element which is here. So which element this is going to be? If you do not remember the element, it's okay. See, this is carbon here. Its configuration will be 2s2 2p2. This will be 3s2 3p2. This will be 4s2 4p2. This will be 5s2 5p2. Is there any option suggesting 5s2 5p2? 5s2 5p2. So this is the option which is our correct answer. Okay. I hope I'm clear to everyone. Perfect. So it's going to be the element 10. It is going to be the element 10. Your Ambika ma'am is calling me. I think I should make her a call back. Just give me a second. Just give me a second, guys. हाँ जी, लाइव सेशन में हूँ अभी यूट्यूब पे. हाँ, हेलो. हाँ हाँ, बना लो. हाँ हाँ हाँ. You want to talk to students? I can keep your phone on loudspeaker. Do you want to? Wait. हाँ जी, अब बताओ.
I'll start the class.
Day after tomorrow, that it's going to be
Yes.
one mega surprise, right?
Sure.
Okay, anything else, Ambika ma'am, you want to say?
Please tell them that
Anything else you want to tell them? Okay, anything else? Okay, anything else? Okay, you had your food? Okay, so keep on having your 16th meal. Yeah.
I just finished.
Chal, bye, bye, rakha phone. Bye, 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 bye. Oh, you did not hear. It's okay. All right. I think this question is done. This question is done. Let's move on to one more. Okay, this is one similar sort of question which we have already solved. And I think you should be giving its answer right in no time. These are again the isoelectronic species. You have to arrange them on the basis of their size. Right? Ionic radius. More the positive charge, lesser the size. 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 Quick, quick, quick. What has to be the answer? Not all of them are isoelectronic. There is K positive also. There is potassium also. What's the answer? Quick. Guys, it's a very simple basic question. Majority of the students have come up with the right answer. It's option A. That's going to be the correct answer of the question. I'm not explaining this one because it's pretty much simple. Moving on to the next one. This is again the simple question. All should be easily solving this. Quick. The set of elements that differ in the mutual relationship from those of other. Okay. Quick, quick, quick. Lithium, beryllium, boron, carbon, nitrogen. Okay. After lithium, what comes? Sodium, magnesium, aluminium, silicon, phosphorus. Lithium and magnesium, they are diagonally related. Beryllium and aluminium, they are again diagonally related. Boron, silicon, they are diagonally related, right? So lithium and magnesium, they are diagonally related. This is correct. Boron, silicon, they are diagonally related. They are correct. Beryllium, aluminium, they are diagonally related. They are correct. Lithium and magnesium are diagonally related, not lithium and sodium. So this is going to be the answer of the question. It's option D, which is the correct answer. Okay, so this is how you can solve these sort of questions. Perfect. What about this one? In general, the property that shows an opposite trend in comparison to other properties across the period. Across the period, generally electronegativity increases. Electron gain enthalpy also increases. Ionization energy across the period increases. Atomic radius size across the period decreases. So this is the exception here. So option D is the one that's correct. This sort of a question should be solved easily. Okay, in the sixth period, the orbitals that are filled. Orbitals that are filled. What do you think about this one? Simple, my dear students. That orbital is filled first, which has got lesser energy. How do you get to know about which orbital has got lesser energy, which has got more energy? Based on your n plus n rule, right? N plus L rule. So if you talk about 6s, n value is 6, L value is 0. So n plus L is 6 plus 0, that is 6. Okay. If you talk about your 5d, n value is 5. For d, L value is 2. So 5 plus 2 is 7. N plus L here is 7. If you talk about 5f, n value is 5. L value for f is 3. So n plus L makes it 8. What is the next one? 6p. So 6 plus 1 makes it 7. Okay. N is equal to 6. L value for p is 1. So n plus L makes it 7. Now, which orbital will be filled first? The one that has got lesser energy, the one that has got lesser n plus L, which has got least n plus L. It's 6s. So 6s will be filled first. After 6s, look at this one, look at this one. N plus L value is same. Now talk in terms of what? Talk in terms of n. Which one has got lesser n? This has got lesser n. Lesser n means lesser energy. So this is going to be the correct answer here. So option C is the one which is correct. Right? So this sort of equation, again, you should be... wait. Sorry. I have given the correct answer here. Incorrect answer here, I think. In the sixth period, the orbitals that are filled first. So first of all, it's going to be 6s. Then you have got... okay, there is 4f, not 5f. Okay, 4f is also given. 4f is also given. So n value is 4. For f, L value is 3. So 4 plus 3 again makes it 7. Right? So 7, 7, 7. Where is the least n now? Least n is here. So 4f has to be filled, not 5d. 4f has to be filled. So it has to be option D then. Sorry, option B then. Right? Option B has to be the correct answer of this particular question. Okay, moving on to one more. This question you can kill now. The atomic number of the element nil unium. Un means 1, nil means 0, un means 1. So it's going to be 101, right? It's going to be 101. Tell me the answer of this particular question. Quick, everyone. What do you think? We have got the element whose atomic number is 120. Which element this is going to be? 120. Atomic number 120. So first of all, if you remember few minutes back, I told you about atomic number 118. 118 means its group number was 18. So it belonged to noble gases. It was the group 18th element, right? Now 119. So this element will go towards the alkali metals, right? So 120 will go towards alkaline earth metals, right? So it is going to be the alkaline earth metal here. Perfect. So 118, if it is the noble gas, 119 again will go back to your group 1, right? A 120 will go to your group 2. I hope this is clear. So it is the alkaline earth metal. All right, what about this one? The group number, comma, the number of valence electrons and the valency of an element with atomic number 15. Atomic number 15 is which element? It is phosphorus, right? Atomic number 15 is phosphorus. Phosphorus, first of all, belongs to which group? Group 15, nitrogen family. It is group 15 element, first of all. How many valence electrons are there in nitrogen family? There are 5 valence electrons. And what about the valency of the nitrogen family? Valency of the nitrogen family is 3. So the correct answer has to be 1553. 1553 is going to be the correct answer of the question. Perfect. I hope this is also clear. Let me move on to one more and see whether you can solve this particular question or not. What about this particular question? Look at it carefully. It's simple. This is again simple. The element having greatest difference between its first and the second ionization energy. What about this one? The element having greatest difference between first and the second ionization energy. Greatest difference. Quickly, people. Everyone. Quickly, everyone. Absolutely, majority of the students are coming up with option D. Option D is the correct answer. What is the logic behind that? If you talk about the electronic configuration of potassium, it is 3p6 4s1. So when we talk about the first ionization energy, electron has to be taken from this fourth shell. When you talk about the second ionization energy, electron has to be taken from the third shell. So the difference in the first and the second ionization energy here in case of potassium will be the more. Okay? Perfect. It's, I believe, pretty much simple. And you can say this potassium, after losing one electron, it gets the noble gas configuration. And if it gets the noble gas configuration, to take the electron out from the noble gas configuration, right? More energy has to be supplied. That's why the difference is more. Okay? All right. What about this one? Look at it carefully. Again, a simple question which you can, I believe, solve easily. In general, the properties that decrease and increase down the group. First decreases, then increases down the group. Electronegativity down the group. What happens to it? Down the group, electronegativity decreases. Okay? And down the group, atomic radius increases. I think this is going to be the option only. In general, the property that decreases and increases down the group. Yes, option 1. No need to think a lot in this question. It's a basic chocolate question, I must say. Okay? What about this one? What about this one? The ionic radius of N trinegative, O dinegative and F negative are respectively. So you have got N trinegative, you have got O dinegative, you have got F negative. They are the isoelectronic species. More the negative charge, more is going to be the size. So its size is going to be maximum, right? Its size is going to be comparatively lesser. Its size is going to be the least among all. Now, check the values. Check the values. The first value has to be maximum. The first value has to be maximum. So this is going to be 1.71 angstroms. This is going to be, for example, 1.40 angstroms. And this is going to be 1.36 angstroms, right? So this is going to be the option here. So it's supposed to be option C. That is the correct answer of this question. All right. Look at this one. The first ionization potential of sodium. The first ionization potential of sodium. So when you take electron out from sodium, this is what it means. How much energy is required here? Energy required here is 5.1 electron volts. The value of electron gain enthalpy of Na positive. Electron gain enthalpy of Na positive. So Na positive, 1 electron. it gets converted into sodium. Can I say this reaction is just reverse of the above reaction, right? Perfect. So I would say electron gain enthalpy would be simply reverse the sign. So minus 5.1 electron volts. We have solved these sort of questions in periodic table. I hope you know. Yes? How do you know I'm coming to Pondicherry? How do you know I'm coming to Pondicherry Center? Yes, on this Sunday, I'll be visiting the new center of Unacademy, which is being opened in Pondicherry. So yeah, on 16th, I'll be there. Anyone who's from Pondicherry can join in. We can meet, we can catch up. That's great. All right, guys, moving on to one more. What about this one? The set representing the correct order of first ionization potential. Quick, this is again easy question. The set representing the correct order of first ionization potential. See guys, if you see beryllium, magnesium, calcium, down the group, ionization energy decreases. So beryllium has got maximum ionization potential, followed by magnesium, followed by calcium. Perfect. So beryllium, magnesium, calcium is going to be the answer of this question. Okay. Perfect. I believe it's clear. All right, look at the next one. Try solving this. And let me know its answer quickly, people. Which of the following has the maximum number of unpaired electrons? It is directly Fe di positive here. If you talk about the outermost configuration of iron, it is 3d6, 4s2. Now, if you talk about Fe di positive, so take 2 electrons out, so it becomes 3d6 configuration. How this 3d6 configuration looks like? 1, 2, 3, 4, 5, and 6. So how many unpaired electrons do you see here? There are 4 unpaired electrons, right? And maximum is this only. If you check all the other things as well, right? Check Mg di positive, Ti tri positive, vanadium tri positive, you'll find the maximum number of unpaired electrons in case of Fe di positive only. You can check here, in case of Mg di positive, there is no unpaired electron. Titanium tri positive, there is 1 unpaired electron. Vanadium tri positive, there are 2 unpaired electrons. Iron di positive, there are 4 unpaired electrons basically. Okay. Perfect. All right. I'm moving on to one more. What do you think about this particular question? Will you be able to solve? Will you be able to solve this one? Will you be able to solve this one? Amongst the elements whose electronic configurations are given, the one having the highest ionization energy. People, if you look at the options, here you have got 3p1 configuration, partially filled. 3p3, half filled. Partially filled, half filled. And ionization energy in case of half filled configurations are more. Now, among B and D, where do you think ionization energy will be more? See, here the electron is present in third shell. Here the electron is present in fourth shell. Here the electron is close to the nucleus. So more attraction, more energy is required. Perfect. So it has to be option B. Simple and basic question again this is. You should be in a position to solve this. Okay. It's a simple question, I believe. Sodium, magnesium, aluminum, silicon. And I believe a lot of students will do a mistake in this. Quick, everyone. Tell me its answer. Aisha, basically day after tomorrow we are taking a combined session. Me, Yavar and Ambika ma'am. Okay, we are taking a combined session. It's going to be a surprise for you. In that combined session, let me tell you what that surprise is, by the way. Okay. So basically in one of the sessions, I gave you the most important chapter-wise topics of physics, chemistry, and biology. They were almost like, I think, some 150 to 200 topics, right? We'll be doing those 150 to 200 topics here with all of you. That is the surprise. But still, I would want you to join the session, which is on day after tomorrow, live session at 8 p.m. Okay. So we'll tell you in detail, basically, what it's going to be. All right. You have got sodium. You have got magnesium. You have got aluminium. You have got silicon. What is the outermost configuration of sodium? It is 3s1. Outermost configuration of magnesium, 3s2. Right? Outermost configuration of aluminium. What is it? 3p1. Okay, and this is 3p2. Perfect. These are the outermost configurations. Now, my dear students, look carefully. See, first of all these elements, they belong to same period. Along the period, what happens to ionization energy? Ionization energy increases along the period. So expected order is this. This is the expected order, right? But what is the actual order? If you look at this configuration and this configuration is fully filled, 2 electrons. This is partially filled, only 1 electron. To take electron out from fully filled configuration, more energy is required. So I must say magnesium should have more ionization energy than that of what? Than that of aluminum. So this is the actual order here. This is the actual order of first ionization energy. And the option which is suggesting so, that is option A. Okay? That is option A. I hope this is clear to everyone. Remember this particular question also. I told you already, a lot of students are going to make a mistake here, right? And that's what you did, I believe. Okay? So this is going to be the correct answer. All right. See, the electronegativity of the following elements increases in the order of. You are given with silicon, phosphorus, carbon, nitrogen. See, first of all, one thing is very clear. Fluorine is the most electronegative, followed by oxygen, followed by nitrogen. This is not given in the options. This is not given in the options. So nitrogen has to be the maximum electronegative. So option C is suggesting so. Don't look at any other things. Option C is the direct answer. Don't worry. Okay. Moving on to one more. The hydration energy of Mg di positive is larger than. Hydration energy. If you remember, your hydration energy is directly proportional to the charge, inversely proportional to the size. Okay. This is your hydration energy trend. If you know. So hydration energy is directly proportional to charge. Hydration energy of Mg di positive will be larger than that ion which has got lesser charge. Now, which has got lesser charge among them? It is Na positive. So direct, Na positive. Okay. So that's why inorganic chemistry we consider as the scoring subject, because it does not take a lot of time to solve the question here. Perfect. So make sure you study this inorganic chemistry properly. All right. Tell me the answer of this particular question. Let me see if you can solve this properly or not. Here they are asking about the second ionization potential. Second ionization potential of carbon, nitrogen, oxygen, and fluorine. Carbon, nitrogen, oxygen, fluorine. They are not talking about the first ionization potential. They are talking about the second ionization potential. So what is going to be the order of the second ionization potential here? You should be in a position to solve this question on your own. You should be in a position. Guys, just give me a second. I'm getting one important call. Hello? हाँ जी, YouTube पे live हूँ. Okay. Guys, they are not talking about the first ionization energy. They are talking about the second ionization energy. So basically, the outermost configuration of carbon is 2s2, 2p2, right? This is 2p3, this is 2p4, this is 2p5. Okay? Perfect. Now take one electron out from here. This becomes 2p1 configuration. Take one electron out from here. This becomes 2p2. Take one electron out from here. This becomes 2p3. Take one electron out from here. This becomes 2p4. Here we were talking about the first ionization energy. This was ionization energy first. 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 Now they are asking about the second ionization energy. So we have to take electron out here from 2p, right? Here also from this 2p2 configuration. Here also from 2p3 configuration. Here from 2p4 configuration. Perfect. So this 2p3 configuration is fully filled. Sorry, it is half filled configuration. So to take electron out from here, more energy will be required. So I would say second ionization energy of oxygen has to be maximum. Second ionization energy of oxygen has to be maximum. Perfect. Now, to take electron from 2p4 or 2p2, where do you think more energy is required? To take electron out from 2p4 or 2p2? To take electron out from 2p4, more energy will be required, because 2p4 configuration, this is more protons more means more nuclear charge. More nuclear charge means more attraction towards the electron. So more energy is required. So first priority has to be given to oxygen. Second priority has to be given to fluorine. So this has to be the correct answer of the question, right? I believe all of you should be in a position to solve this sort of a question on your own. Okay. Well, this question again is of the same pattern and you should be in a position to kill it in very lesser time. The correct order of radius. First of nitrogen, beryllium, boron. Nitrogen, beryllium, boron. What do you think is going to be the correct answer? See, guys, one thing I've been teaching you from first minute itself. These are your isoelectronic species, more the negative charge, more the size. So this is the correct order that's given. I need not to check all the other things. I need not to check all the other things. Okay? Perfect. Perfect, people. Okay. This sort of a question also comes in your exam. And again, you should be able to solve this on your own. What do you think? The 5 successive ionization enthalpies of an element are given this. Okay. The number of valence electrons in the element is. Look at the first ionization energy that's given to us. So to take the first electron out, how much energy is required? 800 electron volts or kilojoules, whatever is given. To take the first electron out, this much energy is required. To take the second electron out, this much energy is required. To take the third electron out, this much energy is required. To take the fourth electron out, look at the jump. It is 25024, right? And then to take the next electron out, it is 32823. Perfect. To take the first electron out, this much energy is required. Second electron out, this much energy is required. Third electron out, this much energy is required. Then to take the fourth electron out, look at the energy gap. There's a massive energy gap. It is telling me just one thing. In the outermost shell, there should be 3 electrons. So to take the first electron out, 800 joules required. Second electron out, this much energy is required. Third electron out, this much energy is required. Now the fourth electron that has to be taken out. Lot of energy is required. Energy gap is maximum, so it has to be taken from inner shell. It would be present in the inner shell. So how many valence electrons are there then? There are 3 valence electrons. So this is how you can solve the sort of equation, a basic one. Okay. Now let's move on to your chemical bonding chapter, from which you get every year almost like 4 questions. 4 questions from the chemical bonding chapter, almost you get every year. We'll be starting with a simple basic question, a confidence booster. Tell me the answer of this one. Everyone. Quickly, people. The question is, the attractive force which holds the various constituents together in a chemical species. What do I call this as? Chemical bond. Right? Nothing to think here. It's a basic question. Second one is also basic. Cation and anion combines in a crystal to form which of the compound? Ionic compound. Okay. No need to think. No need to explain, I believe. Okay. When the metal atom combines with the non-metal atom, metal loses electron, forms the cation. Non-metal atom gains electron, forms the anion. Then there is attraction between cation and anion, and by means of which ionic bond formation takes place. Okay. So what is the answer? The non-metal atom will gain electron first of all. Okay. And when non-metal atom gains electron, it gets converted into anion. Its size increases. So increase in size. So option D is the one which is correct. Okay. Tell me the answer of this one. Tell me the answer of this one, everybody. I'm given with 4, 5 species. I have to check which of the following does not represent the correct Lewis structure. See, if you talk about carbon, carbon has got 4 valence electrons. Is that 2, 4? Its atomic number is 6. So there are 4 valence electrons, and 4 valence electrons are specified here. Oxygen has got 6 valence electrons. Only 5 are specified. So this is not the correct one. Okay. In the neon, there are 8 valence electrons. Only 6 are specified. Beryllium, 2 valence electrons, 2 are specified. Boron, 3 valence electrons, 3 are specified. So 2 and 3 is going to be the correct answer. Okay. 2 and 3 is going to be the correct answer. According to Fajans rule, covalent bond is favored by. From the Fajans rules, every year you get a lot of questions. Okay. As per the Fajans rule, covalent character is favored by. See, covalent character is directly proportional to what? Polarizing power of cation, as well as covalent character is directly proportional to the polarizability of anion. You should be knowing this. Now, this polarizing power of cation, if you remember, polarizing power of cation, it's directly proportional to charge on cation, inversely proportional to size of cation. Remember these things? And when I talk about the polarizability of anion, it's directly proportional to charge on anion, right? As well as the size of anion. Now tell me the answer. It's clear now? It is clear now, people. Quick, everybody. Quick. Quick, people. Quickly, guys. Everyone. Quickly, this is a simple question. Everybody. Just give me a second. Just guys, give me a second. Just a second. Okay. So first of all, according to Fajans rules, covalent bond is favored by smaller cation and larger anion. Right? Smaller cation, larger anion. This is pretty much simple now. I believe you would have easily solved. The sequence of polarizability. Polarizability of anions. Polarizability of anions. I told you right now, polarizability of anion depends on charge on anion and size of anion. Right? Now, the charge on every anion is same. Talk in terms of size. Talk in terms of size. More the size of anion, more the polarizability. So, this is the order. I negative has got maximum size among all. The covalent bond character. Covalent bond character. First of all, LiCl. This is Li positive, Cl negative. This is Be di positive, Cl negative. This is boron plus 3, Cl minus 1. This is carbon plus 4, Cl minus 1. The anion everywhere is same. Anion everywhere is same. So we'll be talking in terms of cation. More the charge on cation, more the polarizing power of cation, more the covalent character. So where do you think covalent character should be maximum? In case of CCl4, covalent character should be maximum. CCl4, then BCl3, then BeCl2, then LiCl. So this is the order of covalent character, right? Yeah? I hope this is clear to everyone and you have solved the question. Okay, the maximum covalent character is shown by. These are basic questions now, and these are asked. These are asked. This is aluminum tri-positive here, this is magnesium di-positive here, this is cesium positive, this is Sn plus 2. Where do you see more charge on cation? In the first option itself, I can see more charge on cation. More the charge on cation, more the polarizing power of cation, hence more the covalent character. Right? Hence more the covalent character. Simple. Similar sort of question, if you see carefully. This is Pb di positive, Pb di positive, Pb di positive, Pb di positive. This is Cl negative, F negative, I negative, Br negative. Right? Now, anion here is different. Anion here is different. But the charge on every anion is same. Talk in terms of size. More the size of anion, more the polarizability of anion. More the polarizability of anion, more the covalent character. So, PbI2 will be having maximum covalent character. First of all, if I talk about covalent character, PbI2 has got maximum covalent character, followed by PbBr2, followed by the first one, followed by, sorry, not the first, yeah, followed by the second one. This is the order of covalent character. If this is the order of covalent character, what will be the order of ionic character? Order of ionic character is going to be reverse of this. This is going to be the increasing order of ionic character. This is going to be the increasing order of ionic character, but we have to write the decreasing order of ionic character. Decreasing order of ionic character is going to be the same. 3, 4, 1, 2. No, this is the increasing order of ionic character. We have to write the decreasing. So, 2 has got the maximum ionic character, then comes your 1, then comes your 4, then comes your 3. This is the decreasing order of ionic character. So, which option is this? 2, 1, 4, 3. It has to be option D, which is going to be the correct answer here. Tell me the answer of this one. Again, the question based on the same concept. I believe you can solve easily. Quickly, guys, everyone. Everyone, guys. Select the most ionic, most covalent. See, chromium in case of CrO5 shows plus 6 oxidation state. This magnesium, sorry, this manganese here is in plus 7 oxidation state. This lead here is in plus 2, right? This will be plus 7. This is plus 6. This will be plus 3. This is plus 6. This will be plus 4. Okay. Now, guys, if you think properly, I have to check what? Most ionic and most covalent. First one should be most ionic. Most ionic means less covalent. Basically, I have to check less covalent. Less covalent I would write first, then I would write more covalent. then outright more covalent. Now, which one is going to be more covalent among the second terms? More covalent. It's going to be Mn2O7 for sure, right? So either option A or option B. Now, less covalent. Less covalent is going to be Pb di positive. So option B is the one that's the correct one. Okay, I believe this is again very much clear to every one of you. Again, a similar sort of question. Again, a similar sort of question. Arrange the following on the basis of their covalent character. It is the same question. AlCl3 will have maximum covalent character because Al has got maximum positive charge, Al plus 3. So this is a simple question. Again, I'm not solving this one. Tell me the answer of this one. Quick, guys. Tell me its answer at least. Quickly, quickly, quickly. Quickly, guys. We have got BF3. BF3 is a molecule whose net dipole moment is 0. You know it already. Okay. You have got hydrogen fluoride here. Its dipole moment won't be 0. So this option is not the correct one. NF3. Its dipole moment is non-zero. So this is not the one. Now BF3. Second is BEF2. This is the molecule whose net dipole moment is 0. Carbon dioxide. This is the molecule whose net dipole moment is 0. 1,4-dichlorobenzene. 1,4-dichlorobenzene. Its net dipole moment is 0. So it's option C. That is the correct one. That is the correct one, right? Perfect. I hope this is clear to everyone. Yeah? It's a simple question, guys. You can remember it like this. You can remember it like this as well. Any molecule of the type AB2L0, AB3L0, AB4L0, AB5L0, AB6L0, AB2L3, then AB4L2. These are the set of the molecules whose net dipole moment always is going to be 0. Okay? Just check the type of the molecule and eventually you can write the answer. The correct order of dipole moment. The correct order of dipole moment. First of all, more the electronegativity difference between the atoms, more the dipole moment. This is the first thing which we see always. More the electronegativity difference between the atoms, more is going to be the dipole moment. You know it. You know it. This is the first thing which we always see. I mean, most of the times. Now, tell me the answer. See, BF3 is the molecule which has got 0 dipole moment. So, it cannot have maximum. So, this is not the answer. Okay. BF3 has got 0 dipole moment. It has to be at the beginning, right? So, it can be C or D. It can be C or D. Now, among NF3 and NH3, among NF3 and NH3, which has got more dipole moment, this question we have solved hundreds of times. NH3 has got more dipole moment than NF3. NH3 has got more dipole moment than that of NF3. So it's option C definitely, which is the correct one. Okay, kill this one. A neutral molecule XF3 has 0 dipole moment. The element X is supposed to be, which has got 0 dipole moment. It is BF3, few minutes back only I told you. So the X has to be boron. X has to be boron. Which of the following molecule is polar? Polar means net dipole moment non-zero. That particular molecule whose net dipole moment is non-zero, that is supposed to be polar. And that molecule whose net dipole moment is 0, that is supposed to be non-polar. That is supposed to be non-polar. What is the type of this molecule? Type of this molecule is AB4L1. Type of this molecule is AB4L0. Type of this molecule is AB4L2. Type of this molecule is AB3L0. Few minutes back only I told you. AB4L0, AB4L2, AB3L0. They are the ones which have got net dipole moment 0. So they are non-polar. This will have the net dipole moment non-zero. So this is supposed to be polar. So it has to be option A. And I hope you know how to check the type of the molecule. Discussed in detail in the chapter chemical bonding. Okay. Similarly, similar sort of question. Which of the following possesses the dipole moment? Which of the following molecule possesses the dipole moment? What do you think? What is the type of the first molecule? This is AB6L0. Okay. This is AB2L1. H2S, like water. H2O type. AB2L2. SF4. AB4L1. Okay. AB6L0 will have 0 dipole moment. Okay. This will have some dipole moment. AB2L1. This will have dipole moment. Even this will have dipole moment. So it is B, C, and D. right? It's option C. That has to be the correct one among all. Okay, tell me once in the chats, do you know how to check the type of the molecule? See, I'm directly writing AB2L1, AB2L2, AB4L1. Do you know how to check it? Just tell me that. Do you know how to check it? Do you know how to check it? Quick. Okay, a lot of students are saying no. Okay, I'll give you one example. Just if you do not know how to check the type of the molecule, then remember it from now onwards. For example, we have got SF4. Let's say I've got SF4. First of all, which is the central atom? Sulfur. Okay, it is a central atom. So how many valence electrons sulfur has? 6 valence electrons. How many surrounding atoms valence has? 4. Number of surrounding atoms is always equal to number of sigma bonds. Number of surrounding atoms is equal to number of sigma bonds. So sulfur had 6 valence electrons. Sulfur had 6 valence electrons. And it's forming 4 sigma bonds. Sulfur had 6 valence electrons. It's forming 4 sigma bonds. So out of 6 valence electrons, sulfur has utilized 4 valence electrons and formed 4 sigma bonds. So there will be 2 electrons left on sulfur as such in the form of lone pair. Okay, so there is 1 lone pair on sulfur. So 4 sigma bonds, 1 lone pair. So the type of the molecule is going to be A, B4 and L1. L1. This is going to be the type of the molecule. So this is how you check exactly the type of the molecule basically. I hope this is also clear. Now you should be in a position to do it. Okay, PP overlapping is observed in which molecule? PP overlapping. In case of H2 molecule, you observe SS overlapping. This is 1s1, this is 1s1. So the overlapping will be like this, SNS, SS overlapping. Hydrogen bromide. In case of hydrogen, S1 configuration, bromine, P7 configuration. So this is going to be SP overlap. This is going to be SP overlap. Hydrogen chloride is also SP overlap. In case of chlorine molecule, Cl2. So it has got P7 configuration. This has got this has got P5 configuration, not P7. P5, this is P5. This was also P5. Perfect. So it is going to be directly PP overlap here. Perfect. In case of chlorine molecule. So again, no need to check a lot in this question. It's going to be chlorine molecule that shows the PP overlap. Right? We have discussed all of this in your valence bond theory. I hope you remember. Okay. Just a second. What do you think about this one? Which of the following represents zero overlap? Where do you see zero overlap? See, this is the overlap. Positive on same side. This is called as positive overlap. I mean same sign on same side, positive overlap. Opposite sign on same side. This is called as negative overlap. Opposite sign on same side. This is called as negative overlap. Do you see any sort of overlap here? No. It is zero overlap. This is the case of zero overlap. So it has to be option C. That should be the correct answer of this question. Okay, that should be the correct answer of this question. Perfect. A basic question, a confidence booster. You know, C triple bond will be always stronger than C double bond, which will be stronger than C single bond C. No need to check, no need to solve this question. Again, a basic question, a structure is given, we have to check the pi bond electrons. So first of all, how many pi bonds are there? 1, 2, 3, 4. 4 pi bonds means 8 pi electrons. 8 pi electrons. Okay. Molecule not having pi bonds. Molecule not having pi bonds. First of all, carbon dioxide, its structure you know. It has got 2 pi bonds here. Nitrogen, N2, 2 pi bonds. Oxygen, O double bond O, 1 pi bond. Chlorine does not have a pi bond. Okay, chlorine does not have a pi bond. So it's option A, that is supposed to be the correct one among all. Okay, which of the following molecules represent the order of hybridization? sp2, sp2, sp, sp. Look at this carbon. It's forming 3 sigma bonds, so sp2. This is forming 1, 2, 3, 3 sigma bonds, sp2. This is forming 2 sigma bonds, so sp. This is forming 2 sigma bonds, so sp. What do I have to check? sp2, sp2, sp, sp from left to right. So it's option B. Okay, option B. The question is, in the octahedral structure, the pair of d orbitals involved in d2sp3. In case of d2sp3 hybridization, which d orbitals are involved? One is going to be dz square and dx square minus y square. These are the d orbitals which are involved in your d2sp3, or you say sp3d2 hybridization. Similarly, if a question is asked, In sp3d3 hybridization, which d orbitals are involved? Dz square, dx square minus y square, and dxy. Okay. Similarly, if the question is asked about sp3d hybridization, which d orbital is involved? It is dz square. Number 3 points. These can be asked anytime. These can be asked anytime. Now you can easily solve this. AsF5 is the molecule. AsF5. First of all, tell me the type of the molecule. Tell me the type of the molecule. Arsenic belongs to nitrogen family. So the type of the molecule has to be AB5L0. AB5L0. What has to be the hybridization? What has to be the hybridization? 5 sigma bond, 0 lone pair. 5 sigma bond, 0 lone pair. Steric number is 5. If steric number is 5, hybridization involved has to be sp3d. sp3d means S, Px, Py, Pz and dz square. S, Px, Py, Pz and dz square. Which option is it? S, Px, Py, Pz and dz square. So option C has to be the correct one among all. Okay. All right. What about this question? The correct geometry and hybridization of XCF4. Quickly, guys. Everyone quickly in the chats. Quickly, everybody in the chats. Done? Are you done, guys? What's the answer of this question? Okay, we are given with XCF4. If you talk about XCF4, check the type of the molecule. Xenon. How many valence electrons it has? 8. How many sigma bonds? 4 sigma bonds. Right? So lone pairs will be, out of 8, 4 are used. There'll be 2 lone pairs. The type of the molecule is AB4L2. AB4 is square planar. AB4L2 is square planar. Hybridization 4 plus 2 is 6. It is sp3d2. So it is the first option only. It is the first option only. That's the correct one. So the correct shape of the molecule is square planar and its hybridization is sp3d2. Okay, a simple basic question again. Look at this one. Look at this one, guys. Everyone, quick. Quickly, everyone. Bond angle 120. It is directly BCl3. It is AB3L0 type. And you know AB3L0 type is basically your having the bond angle of 120. Okay, water has got the bond angle of 105 and not 109 degree 28 minutes. Since water is undergoing hybridization of sp3. Okay, hybridization of sp3. So it has to be tetrahedral. Perfect. It has to have the tetrahedral geometry. So its bond angle should be 109 degree 28 minutes, but it is 104 degree 5 minutes. What is the reason behind that? The lone pair repulsion in case of water. Yeah. The lone pair repulsion in case of water, the bond angle shrinks and it moves towards 104 degree 5 minutes. Similarly, in case of NH3, again, in case of NH3, The hybridization is sp3. So its bond angle should be, its bond angle should be 109 degree 28 minutes, but it is 107 degree. Okay, remember these points. Tell me the answer of this one. Tell me the answer of this one. Select the correct statement regarding the shapes of PCl5, BRF5 and IF7. What do you think? Quick. First of all, if I talk about PCl5, PCl5 is of the type AB5L0. AB5L0 means? AB5L0 means trigonal bipyramidal. Okay, BRF5. BRF5, 5 sigma bonds, 1 lone pair. So AB5L1, it is going to be square pyramid. Square pyramid. Then we have got one more as IF7. IF7 means AB7L0. So it's pentagonal bipyramidal. Now check the options. All are square pyramidal. No. Incorrect. All are trigonal pyramidal. No. One of the given compound is square pyramidal. Yes, one of the given compound is square pyramidal. So it's option C. It's option C. Okay. Okay, in which of the following molecules the central atom has got more than one lone pair? What do you think? What do you think? Done? More than one lone pair. See, sulfur here has got one lone pair. Xenon has got 3 lone pairs here. Right? Xenon has got 8 valence electrons. So it's forming 2 sigma bonds. So there will be 6 valence electrons left in the form of 3 lone pairs. Perfect. Silicon has no lone pair here. Carbon has no lone pair. So it's going to be XCF2. That's going to be the answer. Okay, XCF2 is isostructural with. XCF2 is isostructural with. If you talk about XCF2, tell me first of all about its type. Its type is AB2L3 type. Okay. Check which of the following molecule has got the same type. If I talk about ICl2 negative, it is going to be of the type also AB2L3. So their type is same. If their type is same, means they are going to be isostructural. They are going to be isostructural. I mean, you can easily solve this sort of equation. You just have to check the type of these molecules. And once, if they have got the same type, so they are supposed to be isostructural. Okay. Which of the following statement is correct? Which of the following statement is correct? What do you think? See, if I look at the option number C, ClO4 negative. Chlorine has got basically 7 valence electrons. There is a negative charge, so 7 plus 1 makes it 8. Oxygen is divalent. Okay, so there will be, first of all, 4 sigma bonds. Since oxygen is divalent, so all the 8 valence electrons are exhausted of chlorine. So there are 0 lone pairs. Steric number is 4 plus 0, 4. Hybridization is sp3. Hybridization is sp3. Type of the molecule is AB4L0. So it has to be tetrahedral. Right? So option C is the one that's correct. Option C is the one that's correct. In case of ClF3, the number of lone pairs of electrons on central atom. ClF3. Tell me how many? Simple. There are 2 lone pairs on chlorine. See, if I talk about chlorine, chlorine has got 7 valence electrons. Out of 7, it has utilized 3. It has utilized 3 to form 3 sigma bonds. So there are 4 valence electrons left as such on chlorine in the form of 2 lone pairs. Right? So no need to think a lot. What about this one? What about this one? Water has got some dipole moment. BeF2 has 0 dipole moment. Why is that? Because BeF2 is linear, water is bent. Right? BeF2 is linear. Right? Its moments cancel out, due to which net dipole moment is 0. But water is bent. Water is bent, due to which its dipole moments, they do not exactly cancel out or something like that. Okay. Identify the wrongly matched pair. Identify the wrongly matched pair. Tell me. NH3. NH3. Its type is AB3 L1. So it's supposed to be pyramidal, right? Correct. PCl5. PCl5 is of the type AB5L0. So trigonal bipyramidal. But here they have mentioned trigonal planar. So this is incorrectly matched. So this is our correct answer. Okay, this is our correct answer. Okay, I hope this is very much clear to everyone. Okay, tell me the answer of this one quick. Guys, this is going to be the level of the questions which you are going to get in the NEET examination. Don't worry. Okay, you are not writing some JEE advanced examination. These are going to be the questions only which will be asked. Don't worry about it. Don't think a lot. It's okay. In case of XeOF4, XeOF4, how many valence electrons with xenon? 8. How many surrounding atoms? 5. Okay. How many lone pairs? See, 4 sigma bonds and oxygen is divalent. So 4 plus 2 consider 6 bonds. So 6 electrons considered as exhausted for this xenon. So out of 8, 6 are used. So there are 2 electrons left as such on xenon. The type of the molecule is AB5L1. Steric number is 5 plus 1, 6. If steric number is 6, hybridization is going to be sp3d2. It is option C. That's the correct answer of the question. Okay. I hope it's clear. I hope it's clear to everyone. Again, you have got the question, which pair of the compound is isoelectronic and isostructural? Isostructural means check the type. If the type is same, you're done. See, if I look at this particular one, we have got IBr2 negative and we have got XeF2. XeF2 we have already analyzed. It's AB2L3 type. Now IBr negative. Iodine is the valence, is the central atom. It has got 7 plus 1, makes it 8 electrons. How many sigma bonds? 2 sigma bonds. How many lone pairs? Out of 8, 2 are used. So 6 will be as such in the form of 3 lone pairs. So it's going to be AB2L3 type. AB2L3 type, their type is same. If their type is same, so they're supposed to be isostructural. They're supposed to be isostructural. I hope this is very much clear to everyone. Okay. These sort of questions also you can expect. So tell me its answer. Tell me its answer. Quickly, guys, quickly. XeF4. XeF4 is AB4L2 type. AB4L2 type means square planar. XeF6. AB6L1 type. Okay, AB6L1 means distorted octahedral. So look at the options. A, you are matching with 2. A, you are matching with 2. B, you are matching with 3. B, you are matching with 3. Now, XeF4, few minutes back only we saw it, right? 5 sigma bonds, 1 lone pair. So AB5L1 type. AB5L1 type means square pyramidal. Okay, so C, you will be matching with 4. Perfect. So This is the answer of the question, which I feel is clear to everyone. Again, a question based on hybridization only. NO2 negative, NO2 negative, then we have got NO2 positive, then we have got NH4 positive. What do you think? Check the hybridization quickly. Check the hybridization. Till now we have solved, this is 159th slide. So we have solved some 80 questions till now. Okay? We have solved some 80 questions till now. And remaining 40 questions you will be solving on your own. I'll be sharing this PDF on my Telegram, which is Wassim Bhat Chemistry Official. This is the Telegram channel name. Okay, right after the session, I'll be sharing this PDF there. The remaining 40 questions you will be solving on your own. Okay. Well, I'll give the solution of all these 40 questions as well. Don't worry. So tell me the answer. NO2 negative. Nitrogen. It is of the type here Ab2L1. Is that? 6 valence electrons, 4 used. Yes, Ab2L1. This is Ab2L0. This is Ab4L0. Now check the type. 2 plus 1 is 3. sp2. 2 plus 0 is 2. sp. 4 plus 0 is 4. sp3. So it is sp2, sp, sp3. sp2, sp, sp3. So option 1 is the correct answer of this particular question. Okay? I hope every single thing is clear, right? And my dear students, this Telegram, check it right now after the session. Okay? The remaining 40 questions are for you and you will be solving them on your own. Okay? I'm taking a leave with this. Do let me know in the comment section whether you want more similar sort of questions and which portion of chemistry do you want me to take next in this. Okay? Chalo guys, I'll be taking a leave. I'll have my dinner now. Okay? Chalo, take care. Bye-bye. God bless you all.